Assalamu alaikum, girls. Good morning.
Good morning, Miss.
It's really good to hear you all. How
Thank
are you?
you, Miss. Fine, alhamdulillah, Miss. How are you?
Alhamdulillah, I'm also doing fine. And first, you just tell me, girls, did you complete writing the current electricity, the note that I gave to you?
Yes, Miss.
Till the end, did you write all of it?
Yes, Miss.
Okay, the last page that I gave you, it was having some symbols and the device I gave. Did you complete that
Yes,
too?
yes, Miss.
Okay, it means that we are almost, in fact, fully done with the note. But as I didn't get the chance to explain to you, I want to do it today. So let us just go for a short review that we had initially with the current electricity chapter. Okay? What do you say, girls? Shall I do that?
Miss, can you repeat?
I want to go for a short review from the current electricity chapter, initially whatever we did. What do you say?
Okay, Miss.
Now, I want you to answer me, guys, so that I can understand that you are with me. Okay. Now, do you remember we discussed about the potential difference and the voltage as well?
Yes, Miss.
Okay. Now, could you tell me what was the unit of voltage? Do you remember that?
V.
V means volt, we say, right?
Yes.
Okay. Now, now for the voltmeter, do you remember we use a device that is called voltmeter that is used to measure the voltage of a certain circuit, isn't it? Hello, girls.
Yes, Miss.
Okay, fine. So, do you remember that in which condition or in which way or in which circuit we do connect voltmeter? Is it in series or is it in parallel? Do you remember that?
Parallel, right?
Yes, it will be always in parallel. So these are the small things we have to remember. Now let's come to current. What was the device that can measure the current in a circuit? Do you remember? What is the name of this device that can measure current in a circuit?
Amper.
Emitter. Yes, emitter. So, and do you remember, girls, that how do we connect emitter in a circuit?
In series.
It is in series. It is in series. Always in series. Okay. And one more difference is there in between a voltmeter and an emitter. Is there anyone who can tell me what is the basic difference between an emitter and voltmeter?
Voltmeter has
Yes.
high resistance and ammeter has low resistance.
Very good, very good. That's the point, because we'll be learning afterwards when we're connecting them, what amount of electricity is passing through and how to calculate, all we'll be doing in this particular chapter. So I think I should go to now. Okay, girls, do you have any doubt regarding the direct current and alternating current? Do you remember those two topics I finished in the class?
Yes.
Okay.
Can you explain them?
Okay, fine, I can do that. Direct current was the one which actually comes from a cell or a battery. The source has to be cell or a battery and it cannot change its direction. It has a single value. Means think about a cell or a battery is providing me 1.5 volt. All through it will give me 1.5 volt. Okay, it cannot change that value. But alternating current, when we are going to discuss about it, it gives us a current which keeps on changing its value. Like it comes from mostly from the mains electricity, means the electrical power station that we have, that can provide us this alternating current. Okay, and it keeps on changing its direction all through the journey. As long as we are receiving it, it will keep on changing. And we do have a curve for that, the one we call sine curve, sinusoidal curve. Is it clear now, girls?
Yes, Miss.
Okay, now you just tell me one thing here. Could you hear my voice loud and clear?
Yes.
Okay, that's better. So I'll go to now. Do you remember one very important point I discussed with you in the class? That is direction of the current. I said we have actually two directions. Means we know the real thing that is happening is that and this is all about DC. It has nothing to do with AC. in DC current, whenever we have the device that is connected to a cell or a battery, it will be always happening. The real thing that is happening is that from the negative terminal of the cell, electrons will come out and go through the whole circuit and come back to the positive terminal. We call it electron flow. You'll remember it is from negative to the positive. But when we come to the other way, means the one we are going to follow all through our syllabus, we call it conventional current flow. That is, it has to be always from the positive to the negative. You remember that because this conventional current flow will mention many times. When we are going to study electromagnetism also, all the time we'll keep on saying that, okay, we'll be using the conventional current flow. So you'll remember. But in paper 4, when we are going to solve the past papers in paper 4, you'll see that they'll ask us that on the following diagram, you have to show the path of electron flow. So that time we'll remember it is actually from negative to the positive. Is it clear to you now, girls?
Yes, miss.
Okay, fine.
Miss, what about from?
Say?
Okay, fine, miss, I understood.
Okay, fine, that's good. So now I want to go to the battery because already we have discussed all of these topics in the class, but I'm just going through one more time because if I don't go through, then you'll not be able to understand the next part. So do you remember that there was two connections, two ways of connecting cells we discussed? One was in series, cells in series. Another one was cell in parallel. So we say that in cell in series, what we do, just we connect in sequence one after another. But in parallel, what we did, all the positive terminals connected to a single point and all the negative terminals was connected to a single point. Then we connected to the rest of the part of the circuit. That was a basic difference between these two. Okay, Nashita, are you there? I want to hear from you. What is the basic difference of cells connected in series and connected in parallel?
Sorry, miss.
Nashita, are you there?
Yes, miss, I am.
Okay, fine. I want to hear from you, dear. Do you remember what was the basic difference between these two, cells in series and cells in parallel?
Yes.
Okay. Could you tell me that?
Cells in parallel will be wait, the difference. Oh, okay.
Yes.
The voltage remains the same
In which connection here? Parallel or series?
in parallel,
Yes.
and in series, the voltage increases.
Exactly. And there was another basic difference. Could you tell me the second point which I wrote in the note is very important to us? About the duration.
Wait. The cells in parallel lasts longer.
Exactly.
Okay.
And in series, it doesn't last long.
It
And
doesn't
that is the, yes, that's really important to us. Okay. Now, let's move on to the resistance. Even though we discussed it before, but I just want to review these 2 points that, okay. First of all, I want to hear from Afifa. Are you there? I want to hear from you, dear.
Hello, teacher.
Yes.
I'm here.
Okay. Afifa, could you tell me, do you remember what is the unit of resistance?
Ohm.
Ohm, yes. Okay. Now, what is the main purpose of resistance in a circuit?
The main purpose.
Yes. In your own words, you can tell me, dear, no problem. What is the main purpose of that? Means, actually, what are those things we are going to learn today? We have resistors that provides resistance in a circuit. But why do we need to have resistors in the circuit? Do you have any idea about that?
To prevent accidents.
Yeah, you're very close. Actually, we have to protect our devices from getting damaged. Because there is any time we can have overflow of electricity that immediately will damage our device, whatever device we are using. Okay, electrical appliances. So to protect it, even if you think about a small diode, we'll be learning it in detail in electronics chapter diode. That also we need a resistance to protect it from getting damaged. Okay, that's a good answer. Thank you, dear. Now let's go to the other part. I want notion. Notion, could you tell me, if I have a long wire and a small wire, what is the difference between these two in terms of resistance?
Miss, I have no idea.
You didn't go through this, dear, Notion?
I did
Okay.
not.
Okay. Now, So if you, do you have the note in front of you?
Yes, I do.
Okay, fine. So could you just go to that topic that we discussed? Factors affecting resistance. There we mentioned the first point, R is directly proportional to L. So from there, could you manage the answer now?
Oh, so the longer one has more resistance.
Exactly, exactly. That's good. Okay, now I want to talk to Afnan Laiba. How are you, dear? Laiba, are you there?
Assalamualaikum, miss.
Walaikum salam. Now, Laiba, could you tell me what is the relationship between a thin wire and a thick wire in terms of resistance?
I'm sorry, what?
A thin wire and a thick wire. In terms of resistance, how will you explain these two wires? A very thin wire and a thick wire. How do they relate to each other in terms of resistance? If you take point, yeah, say point number 2, if you take, you can give me the answer. Yes.
Wait. I didn't go through it, so sure.
Okay. Is there someone who wants to help Laiba? Anu?
The more the area of the cross section, like the thicker the wire is, the less resistance,
Very good.
and the thinner the wire is,
More
the
resistance.
resistance.
Very
Yep,
good.
more
Very
resistance.
good. Yes, that's very good. Yes, that is how we're going to explain this one. And I want Anud. Anud, are you there, dear?
Yes, miss.
Yeah, fine. It's good to hear you. Yeah, I miss you all a lot. Okay, guys. Now, Anud, could you tell me how temperature affects the resistance?
If the temperature increases, the resistance also increases.
Okay, but do you remember it is about the normal conductors? There is something else I told you regarding some other that is having a name, semiconductor. How do they react when the temperature increases?
Oh, when the temperature increases, it conducts more.
Yes, means its resistance decreases. The opposite means?
Decreases.
Yes, yes, very good. That's the correct answer. So now I want to proceed to our topic for today, that is resistance components. I'll go for that, but before that, I want you to just look at the equation that we had, that is equation of resistance. I wrote it R equals to rho L by A. Did you notice? Guys, could you find out that equation?
Yes, miss.
Okay,
Yes,
fine,
miss.
good. So I want, okay, guys, one more thing. I can see only 15 students are here today, but I remember I have 31 students, 32 students it was supposed to be. So how come they didn't come to the class? Any idea, guys? I hope they know, right? About the class. Yesterday I have informed you on the group.
Maybe they couldn't join because they found. I don't know.
But this is really sad. Inshallah, from now onwards, we'll be having regular classes. Okay, now I want, okay, Yanfa, are you there? Yanfa?
Yes, miss.
Yeah, how are you, dear?
I'm good, miss. How are you?
Alhamdulillah, I'm fine. Yanfa, in that equation, R equals to rho L by A. What is this rho? Could you tell me?
Constant or
Yeah, it is a constant. But what is the name of this constant?
resistivity?
Yes, fine, that's good. So hopefully you have gone through the notes, right, till this much?
Yes, miss.
Okay, that's good. Now I will go to the next topic. All of you girls, please pay attention. I'm going to now the new topic that we were supposed to do 2 weeks before. So now I want to do that with you. Resistance components. By the time I have mentioned the word resistors, they are the one which actually gives us the resistance to a particular circuit. And what they actually do in a particular circuit, they protect. Yes, who's that? Yeah, okay, let me continue. So resistors are the components that provides resistance to the circuit. that in fact protects some of the circuit, some of the components in our circuit from getting damaged or to function properly. But you still remember one more thing, that whatever components we are making, like the device and the appliances that we are using, each and every component do have their own resistance. At the same time, we do have the wires that we are using, the one we call connecting wires. They also do have some resistance. Okay, so it means that resistance is a must in a circuit, but along with that resistance, we have the electricity passing through it. Okay, so what type of resistors we can use in a circuit? We have two types. One we call, that is called fixed resistor. The other one is called variable resistor. Both of them are very important, but the first one is that the fixed resistor, if you just look at there, I drew the symbol of it also. It can provide a certain amount. You cannot change it. Means it's not variable. If it is written that 5 ohm, then in the circuit, it will only provide 5 ohm. We cannot change that value. Okay. But when we have the second one, that is the variable resistor, it has another name, rheostat. Okay, it has another name, rheostat. That one is like that we can change whenever we feel like. I can increase the value, I can decrease the value according to my particular circuit. Okay, guys. So now one more thing is there. Okay. One more thing is there, girls. Did you notice that there is a symbol I have given to you?
Yes.
Yes. Yeah, that symbol you'll be checking very carefully, because we'll be using this symbol many times. Many times we'll be using, and then you have to show that one, and you have to place it in a circuit, where to place, we have a certain way. Now you'll remember one more thing. Okay, before that, let me just go back to the thing, nichrome wire. First of all, what is this fixed resistance? It is actually nothing but a small piece of wire coated with ceramics or some other insulating material. I hope you know that ceramic is a electrical insulator. Did I mention that before? I don't remember actually, but I hope I have mentioned it. But you'll now remember. Okay. Now another one I want to discuss with you, that is a nichrome wire. Okay, I'm not sure how many of you have seen the lamps or the bulb we call, the round bulb, the one we use in Bangladesh a lot. Here I think we don't use that much. The round bulb. Did you notice that one, girls? Yes, there you can see that a thin wire can be seen from outside. Did you notice that? A thin wire can be seen from outside, and when the lamp is shining, you can see that the thin wire is glowing. In fact, that is the wire made up of nichrome. And what is a nichrome? It is actually an alloy which is made up of nickel and chromium. That wire can also be made up of tungsten, but nickel and chromium, they have a percentage like 80% of nickel and 20% of chromium together will make a nichrome wire. And it has a very high melting point. That is why it is used to make this lamp, because when electricity passes through it, the temperature goes really high. And then it glows and then gives us the light from that. Okay. Now I want to go to the next topic. Okay. Now, guys, I want you to check the next topic that I have, resistors in a circuit.
Miss, I have a question.
Sure. Say dear.
In variable resistor, there are two symbols.
Both
What are the
usually.
differences?
No difference here. Both are approved and both you can use. In fact, in our syllabus, you'll see that the first one we use a lot. But sometimes they give the second one also. Don't get confused. This is also a variable resistor.
Miss, in the electrical symbols, you named one variable resistor and the other one potential divider.
I will tell you what is that. I'll tell you. Both of them are variable resistor, and this arrangement is like that when you keep the, okay, let me tell you one thing, Nashita, this potential divider, don't discuss it. Let us not discuss now, because grade 10, first thing we'll discuss it. Now you'll not get this one immediately. Okay, it's kind of a different point. So let us stop it, but you'll remember both of them are variable resistor. When a variable resistor is connected in a way that it solves or it performs another type of work, that one is known as the potential divider. Okay, Now, let me continue with this one.
Miss,
Yes, dear.
thin nichrome and tungsten, they're the same thing.
No, dear. Nichrome is an alloy made up of nickel and chromium. Tungsten is a separate metal, separate element that is also used to make the electrical wires, which are having a very high melting point. That is also used to make electrical appliances. Tungsten wire.
Okay, thank you.
You're welcome, dear. Now, let's go to the next topic that is very important to us, that is resistors in a circuit. As I said, we are going to discuss all the time two types of circuits. One is a series, another one is a parallel. First one, if you just look at the diagram, when resistors are connected in series, the combined resistance always increases. This point is so important, guys. Always increases. Means, and it is a voltage division circuit. Now, voltage division, what do we mean by that? I'll explain to you now, listen. If you look at the circuit, did you notice that I have given a source of electricity that is having a voltage V, and I have connected two resistors R1 and R2 in series, right guys? Okay. After connecting, did you notice I have given an arrow to show the direction of the current? Did you notice, girls?
Yes.
Yes,
Okay,
miss.
fine. Now, did you notice now? I want, Tajrian, are you there? Okay, Tajrian, could you tell me what type of direction I have shown in this particular circuit? Tajrian, are you there? I'm talking to you. Hello. I think she's not there, right? Okay. Now then, Rahma, are you there? Okay, I think Rahma is also not listening to me. Rahma, are you there? Hello.
Yes, miss, I'm here. Sorry, I couldn't.
Okay. Yeah, okay. Rahma, could you just look at the circuit for the resistors in series and tell me which type of electric flow I have shown? Is it conventional or electron flow? With the arrow, which one I have actually showed there?
Miss, sorry, could you repeat?
Okay. Do you have the circuit in front of you? The series circuit?
Yes.
Yes. Okay. Now look at the circuit and tell me what type of direction of current I have shown. Is it a electron flow or conventional current I have shown there?
Potential.
Which one there? Did you understand my question? Okay. Afnan Abdul Kadir, are you there?
Yes, miss.
Yeah. Could you tell me what type of connection I have given to that circuit? Is it a conventional current direction I have shown or the electron flow?
Miss, I don't have the notes with me right now, but I do know that from positive to negative, it's the direction of the conventional current.
Very good.
And from negative to positive.
Yeah, very good. Because it is the conventional current direction. But you should have your note in front of you there when you're having a lesson. Please keep it with you. Okay, excuse me, girls. Who's this? Abiyat Hassan? The name came.
That's Nimra.
Oh, that's Nimra. Okay, fine. Because her name is not there, I couldn't understand. Okay, fine. Now, girls, look at the diagram one more time. First of all, I mentioned one thing, that the resistance will increase. So, all of you just go down and check. There is a box I gave and I wrote RS equals to R1 plus R2. Did you find?
Yes.
Okay. It means that actually, if you just look at it, RS equals to R1 plus R2, as I mentioned earlier, that the resistance will increase. That means the whole thing. In your exam paper, nobody will ask you to derive the equation, but I showed it to you so that you can do the calculations with the help of this equation. Now, let's go back on the top. I wrote it, in series circuit, current remains the same in all the components. So what does it mean? Think about in this particular circuit, right now I have 0.5 ampere current passing through it. It means that R1, R2 both will get 0.5 ampere current. There will be no change about it. But the voltage, think about my two cells that I drew there, they are providing me 10 volt electricity. That 10 volt will not be gone to R1 and R2 both. It will be divided into these two according to their own resistance. Girls, are you following me?
Yes, Miss. Can you explain again?
Yes, I want to do that. Listen to me. So as I say that, first of all, you'll remember it's the voltage division circuit. Means whatever voltage you'll be giving in the source, it has to be divided into the number of the appliances that you have already connected. Okay, so when we are using or giving connection to some of the appliances in the series connection, all of them will get a certain portion of the voltage of the main circuit. Clear? Now, let's come to the calculations. What I wrote. Just imagine that in this circuit, we don't have two resistors. I have a single resistor. That is given a name RS. That is the equivalent resistor. So, from the equation, we know that we'll be writing V equals to IRS. Okay, V equals to IRS. Because the equation we already got R equals to V by I. From there, I wrote the equation. Just rearranging the equation to get the voltage. And then, for each resistor, consider the first one is having V1. So V1 equals to IR1, V2 equals to IR2. Okay. Now, what I did, I just added them two. Like V equals to V1 plus V2. As I said, it's a voltage division circuit. So I have to add them to get the total voltage. Right, guys? Then I just rearranged the equation and finally I got RS equals to R1 plus R2. Okay, now I want to ask you a question. Mukaroma, are you there? This question is for you. I want to ask you a question. Think about, I have connected 3 ohm and 5 ohm in series. Could you tell me what is the equivalent resistance there? I'm asking Mukarama. Are you there? Yes,
Miss, can you repeat once again?
Yes, I can do that. Listen to me. I have connected 3 ohm and 5 ohm resistor in series. Could you tell me what is the value of the combined resistance now?
3 ohm plus 5 ohm.
Yes. So what is the total resistance of this circuit now? Series. In series, I have given connection.
8 ohm.
Very good. That's what. So we understood that this 8 ohm resistance is actually the total resistance of the 2 resistors that we have connected. And we have to remember one more thing, guys, that whenever you give a connection of series, the combined resistance always increases. This is very important point for us. That's why I mentioned it initially. The combined resistance always increases. And it is a voltage division circuit. Now, let me ask you another question. Okay, this one I want to ask, whom to ask? Okay, Nimra, are you there? Nimra, I want you to give me the answer of this question. As I said that 3 ohm and 5 ohm, 2 resistors, I have given connection, right? So, who's going to get more voltage from the source? Could you tell me? Nimra, are you there?
Miss, can you repeat the question?
Yeah. I asked you that as I already asked Mukarama that if 3 ohm and 5 ohm, 2 resistors are there. I have given them connection in series. I want to know who will get more voltage from the circuit. Who will get more voltage from the circuit? Is it the 5 ohm or the 3 ohm? Nimra, are you there? I want to hear the answer from you. I think Nimra is not there. I can hear her. Okay, then who can give me the answer? Nashita, would you like to give me the answer? Among the 2 resistors that have connected 3 ohm and 5 ohm, who will be receiving more voltage from the circuit? Which resistor, 3 ohm or 5 ohm? Nashita, could you give me the answer, please?
Is it the 5 ohm?
Very good answer. No, it is the correct answer, dear. You'll remember the one with the more voltage will receive more more electrical energy from the circuit. And you know, the one we are discussing now, that is called the potential divider circuit. It has another name. I told you, right? I'm going to discuss with you later. This is actually known as the potential divider circuit as well. But this one we'll discuss in another way in grade 10 electronics chapter, that is called the potential divider. Okay, but right now you'll remember that series circuit is known as voltage division circuit, is also known as a potential divider circuit, because the potential itself is getting divided among the appliances. Got it now? Nashita?
Yes, miss. Yes.
Okay,
Yes.
fine. Now let's go for the next one. That is called the parallel circuit, which is very important for us. Now, if you just look at the diagram, did you notice that there is two resistance which are connected in a way where two common points are there, and then that is connected to the cell?
Yes,
Yeah,
miss.
very good. Turn the page and look at the diagram, then it will be easy for you to understand. Okay. As I told you initially, that the series circuit is a potential divider circuit or a voltage division circuit. In that case, I have to tell you now that a parallel circuit is a current division circuit. Here, the current will get divided, but the potential will remain the same. Means all the appliances is going to have the same voltage, no matter how many you connect them. As many as you connect the devices in parallel circuit, all of them will be having the same voltage, but the current will get divided. Because whenever there's an electricity coming, if you just look at the diagram, after coming to a certain point, it has two paths, and it will go, some portion will go to R1 and some portion will go to R2, and together they will join back. Together they'll join back and come back to the main circuit one more time. So if you just look at the diagram, I wrote I equals to V by RP. RP is the equivalent resistance. There we mention RS as for series. Now P for parallel circuit. Okay. So now let us go for each resistor. Then we can write. Okay. Excuse me, Reen, could you turn off your audio because you're making lots of sound. Reen, yeah, thank you, dear, because your sound is too loud. Reen, I'm talking to Reen.
Yes, miss.
Then we can write again I equals to I1 plus I2, because as I told you, the I current is coming out and it got divided into two parts, I1 and I2. Together they're going to become again I and come back to the main source. So we wrote the equation I equals to I1 plus I2. And I just substitute the value of I1 and I2, and I got the equation 1 by RT equals to 1 by R1 plus 1 by R2. You'll remember this equation is very, very important to us. In the exam paper, if you just write down in any calculation, wherever it is needed, this equation will be scoring 1 mark. So it's very important to us to remember the equation. Now, you'll just remember, after doing the calculation, could you just go to the last end of the page, this page? I gave you two examples. Okay, I want you to look at part A and B. I gave you two examples. Could you follow that, girls? Okay. Nuri, are you there? Nuri, are you
Yes,
there?
miss, I'm here.
Okay, fine. I want you to...
Yes, miss.
Good. Now check one thing. At the end of the page, could you see A and B? Two equations I've given, two calculations I've shown you there. Could you see that?
Miss, actually, like, I'm outside and, like, I just got connected just some minutes ago, so I couldn't bring my copybooks. I'm just listening to the,
Okay, fine. Okay, fine. Then I can ask someone else who can help me.
Sure, miss. Thank you.
You're welcome.
Me, miss.
Okay, I want Sarah to give me the answer. Sarah, are you there? Do you have the note in front of you? Sarah, I'm talking to you. Are you there? Okay, I can't hear her. I don't know whether she's following my class or not. Okay, fine. Let's go back. Okay, Asil, are you there?
Yes, miss.
Okay, Asil, could you take the last two examples that I have given you there?
Yes, miss.
Yeah. Now, I want you to check one thing. I wrote the second calculation, that is 1 by RP equals to 1 by R1 plus 1 by R2. And
Okay.
did you notice at the end, I have to reciprocal it because I'm finding the value of RP. And in the exam paper and anywhere, all the time they'll be asking you to find out the value that is RP, not 1 by RP. So you have to remember that after completing the calculation, at the end, you have to make it reciprocal and then find the answer finally. Because most of the students, what they do, they make a mistake here all the time. They make mistake that they keep 1 by RP as the answer. No, dear, it's not that one. You have to invert it. You have to make it RP. As you see in that question, I got 1 by RP equals to 3 over 6. And I made RP equals to 6 over 3. Then I wrote equals to 2 ohm. Did you notice?
Yes,
okay.
miss.
Very good. Now I want all of you to just turn the page, and I want you to concentrate on the point number 2 there where I wrote, when resistors are connected in parallel, the combined resistance decreases and it will be smaller than the smallest resistance of the combination. Could you just all of you check this point one more time, because it's so important to us.
Where is it, miss?
Yes. Okay. I want whom to answer me. Anuj, are you there?
Yes, miss.
Okay. Anuj, I want you to check this point one more time. As I say, point number 2, that is resistance in parallel. I wrote the resistors are connected in parallel. The combined resistance decreases and it will be smaller than the smallest resistance of the combination. This point you have to learn, and it will be the answer of a question. At the same time, it will help you to solve paper 2. And what I meant by this one, I want you to check that the calculation that I gave you on the next page at the end, that is 1 by RP. I wrote it that 1 by RP equals to 3 by 6 and RP equals to, finally we got 2 ohm. So did you notice that the combination of this resistance is 2 ohm, right? And what are and what are the two that have connected there? That was 3 ohm and 6 ohm, right? So it means that the combined resistance that we found, which is less than the smallest one in the circuit. Isn't it? It's very important point. Yeah, it's a very important point, because in paper 2, they'll ask you without any calculation, you have to say what is the possible answer. The answer will be always that it will be less than the smallest one connected in the circuit. In paper 4, they'll ask you that they'll be asking you this conclusion, that what conclusion we can draw from here. The only conclusion is that the combination of the resistance or the combined resistance will be always less than the smallest one connected in the circuit. Is it clear to you now?
Yes.
Okay, very good, girls. Is there anyone having any doubt in these 2 points? Because these are the 2 circuits we'll be discussing a lot all through our syllabus. So could you tell me, do you have any doubt? Anyone among the 16 students? See, I had 32 students in my class and I got only 16 today. I hope next time the number will increase, because I want to explain the whole thing to everyone. Right, girls? Okay. Now, girls, I hope you don't have any doubt in this particular topic, right, girls? Shall I move on to the next topic?
Yes, miss.
Okay.
Yes, miss.
Okay. Now, I want you to check Ohm's Law, the next topic, which is really important to us because it will lead us to an experimental question that is a very, very important topic in paper 6. As you know that nowadays we have a topic called, the one you'll be doing in grade 10. That is like we are going to have a practical question that is out of 7 marks in paper 6 we'll be doing. That is called planning question. And this particular topic is a very common point in planning questions. So you need to understand it very carefully. First, if you just look at the equation, look at the law that I have given to you, that is called Ohm's Law. Okay. The current flowing through a conductor is directly proportional to the PD across its ends, provided temperature and other factors remains constant. Now, why we have to bring temperature? Because by the time we have learned that whenever temperature increases, the resistance of the particular substance or an element keeps on changing. So we have to ensure that the temperature is not changing. Then, and other factors, think about, I have a copper wire. It cannot have any other impurity inside it. It has to be only copper wire. It should be made up of a pure copper. Then I can say that whatever the current is going to flow through that particular copper wire, it will be directly proportional to the PD across the two ends of the particular wire. And as I said, we have to make sure or ensure that there is no change in temperature. And the other fact, as I said, there should not be any other impurity. It has to be pure copper. Okay. Now we wrote the equation I is directly proportional to V, and we can say at the same time that V is proportional to I. Then we got the equation V equals to IR. Here R is our, you can say it is the proportionality constant as well as the constant quantity in this particular topic. And we wrote I equals to, just rewriting the equation, I equals to V by R and R equals to V by I. Okay. Now come to the next point, that is factors affecting current. As we all the time say that current is passing through this particular device, through this circuit. So why the current will not be the same, or why will it change, and what are the factors that can change it? We need to know. If you look at the equation I equals to V by R, from this equation we can find out the two quantities that is actually going to change the current, isn't it? So I and V, how do they relate to each other? I and V, how do they relate? Afnan, could you tell me? Afnan Abdul Qadir? If you just look at the equation.
They're in proportional to each other?
Directly proportional to each other. Means one increases, other one increases at the same time. Fine. And then, what about resistance? I is, in which way it will relate to resistance? Inversely proportional. Isn't it? Means the more the resistance, the less the current can provide or can pass to the particular appliance. Okay. Now, next one, the one as I say, experiment to find the resistance of an unknown resistor. You remember, this is a practical question, and as I said, it is coming mostly in paper 6 as a planning question. And this full question, a full practical procedure that I have discussed here, you have to learn it. This 2-page question, you have to write down for 7 marks. Okay. So you need to understand and learn the whole thing. Don't think that you don't need to learn it because it's a big question. We don't have these big questions in the physics papers. It's not like that. We do have in paper 6, that is called the planning question. You'll be doing it with me, inshallah, in grade 10. But now you have to learn because we are doing everything all together in the same syllabus. Okay, guys? Fine. Now, first I wrote theory. Theory means which equation we are going to follow in this particular one. It's nothing but the Ohm's law, as we already learned it. V equals to IR, and we are finding out the unknown resistance. So R equals to V by I. We'll be using this equation. Okay. Now, components. All of you check what are the components that I have mentioned? Cells, rheostat. Okay. Now, what is a rheostat? Today we discussed. Rheostat is actually nothing but a variable resistor. Inshallah, if the school reopens, I will be showing you all these devices personally. And by the time, since you are using net all the time, you can just write down the name rheostat and you can see the photographs on the net. On Google, you can search and check all those photographs only. Inshallah, I'll be showing you personally when the school is open. Okay. So next we use voltmeter, unknown resistor, switch, and connecting wire. Okay, guys. Now tell me, do you remember we have a chart in our classroom, grade 9A classroom? At the back of it, yes, there we have these diagrams. All these photographs are there. Emitter, voltmeter. Do you remember that chart in our classroom?
Yes, miss.
Yeah, sure. So there we have all the diagrams. It will be really good if we could go back to the classroom and see all the things. Inshallah, one day it will be like that. Right, girls? What do you say?
Inshallah, miss.
Inshallah. We do miss our school, isn't it? Do you miss, girls?
Yes, miss.
Yeah. Even I miss you all. I feel like seeing you all the time. Okay, guys. Now, all of you turn the page and check there's a circuit I have given to you. All of you just turn the page, next page. I have given you a circuit. Now, in the circuit, is there any component there which you don't know? Just have a look at the circuit and tell me. Is there anything that you don't know?
The rheostat?
Yes, that is the rheostat. RH, the one I wrote, that is the variable resistor. That is rheostat.
Okay, miss. Is it like an arrow above?
Yes, yes. There has to be an arrow across. Across, and then arrow should be on the top. Okay. Now, if you just look at
Miss, can you say again
Okay.
what's the purpose of rheostat?
Okay, a rheostat is the one which can provide us some resistance that can change the current of the circuit by changing the resistance of the circuit. I'll tell you what. Because when you increase the resistance, okay, but first of all, let me tell you, did you notice what type of circuit is that? You tell me emitter, resistor, and rheostat. How do they connect to each other? By looking at the diagram, could you tell me?
Series.
Very good. It is series.
Okay, that's
Yeah,
series.
it is a series circuit. And then voltmeter, if we just look at it, isn't it in parallel circuit?
Yes.
Yes, and it is across R. Means we want to find out the voltage across R. We don't want across emitter. We don't want across rheostat. So I want it across R. Okay, that is why it has to be drawn here. Look, in paper 4, and in paper 6, they'll be asking you to draw the voltmeter in a particular place. They'll ask you to draw the voltmeter across this lamp, across the resistor. So you have to understand what do we mean by the word across. Means it has to be parallel to that particular component, not the whole component, not the whole circuit. Got it? Clear to you girls how to draw a voltmeter in a circuit?
Yes.
Very good. Now let's proceed. The next thing is that look at the procedure. Read it very carefully. First point we have to write down all the time. In paper 6 also we'll be writing. Set up the components in a circuit as in the figure. Okay. Set up the components in a circuit as in the figure. The way it is in our figure, we have to connect the rheostat, the resistor, the emitter, a switch, series connection. Then the voltmeter in parallel connection. After that, see I wrote, keep the resistance of the rheostat at the maximum possible resistance to keep the initial current low and then close the circuit. Now understand it very carefully. A rheostat, let me remind you, think about a rheostat, it is written that 0 to 500 ohm means this particular device can provide me highest 500 ohm resistance, least 0 ohm. And here you have to remember one more thing is that you cannot measure that how much you have given to the circuit. Here we cannot measure, but we can just keep on changing it. The arrangement is like that you can change it, but you cannot measure how much you are providing. So just imagine when you are giving it to the highest part, means 500 ohm, then what is the total resistance of the particular circuit now? Is it very high or very low? Could you tell me, yes?
Very high.
It is very high. Very good. It is very high because it's a series circuit, and we learned by the time that in series circuit, the resistance connected in the series all will be added and it will increase. So when we are giving more resistance to the circuit, definitely the current will be small, isn't it, girls?
Oh, okay, miss.
Yeah, fine. So now let's come to the point that when we have given the highest amount of resistance and the initial current has to be low, and then close the circuit, means we'll switch on the circuit, means close the switch, and we are going to note the reading that is coming on the voltmeter and the emitter. So we wrote, note the values of current I and the voltage V of the circuit from the emitter and voltmeter. Is it clear this point, girls? Okay. Now
Miss,
let's
can you repeat?
means after switching on the circuit, what we said initially, we're going to keep the resistance, means resistance to the highest point of the rheostat, and then we're going to switch on the circuit. After switching on, current will start passing and we'll get the reading of the emitter and the voltmeter. Okay, so we are just going to note it and find the value of the unknown resistance by using the equation R equals to V by I. So this is one time you did the practical, one time you got the resistance R. Then we are going to decrease the resistance of the rheostat by moving the sliding contact to change the current. Actually, there is a contact with which you can keep on changing the resistance in the rheostat. So as we have started with the highest value, now we'll keep on decreasing it and get few more values. And mostly we'll be trying to do 5 times because we're going to draw a graph. And the graph is also very important to us. So minimum 5 values are needed to draw a graph. Right, girls? Okay. So now I wrote, repeat steps 3, 4, and 5 few times and find an average value for the resistance. Then note down the findings in the following table. Now all of you will remember this, as I said, this question I made for paper 6. In paper 6 also, you have to draw the table like this with the column heading, but the whole table will be empty. You don't need to put any readings there. Got it, girls? You don't need to put any readings. You'll be just continuing with the table. And the column heading has to be there. I wrote voltage, current, resistance, average. Means you will be doing it 5 times, take an average, that will be the value. Okay. Now, I want to ask another question to Noshin. Noshin, are you there?
Yes, miss.
Yes, yeah. I want to ask you a question. As you see the diagram, the way I gave you means the graph that I'm talking to you. I wrote the last point, plot a graph on the graph paper, VI graph we call it, for different values of V and I from the table, right? I wrote it like this. So after drawing, did you notice a particular shape of the graph? Hello?
No, I don't understand it.
No, Noshin, did you notice a particular pattern of the graph that I have there? How do you say this graph? Means how do you explain this graph? How does it look like to you?
Maybe it's like proportional.
Yeah, it means it's a straight line. It's a straight line from the origin. This is a very important point. You have to write down in all over the exam paper, everywhere you have to mention. They will ask you what will be the pattern of the graph. You have to mention the graph will be a straight line from the origin with constant gradient. And you know that whenever it's a straight line, it will always be having a constant gradient from the origin, isn't it? And they'll be asking you that what is the pattern? And when it is like that, what conclusion you can draw? The conclusion is that the two quantities that we have here, V and I, they are directly proportional to each other. And since they're directly proportional to each other, they'll give us a constant gradient. That gradient is actually nothing but the unknown resistance, the one that we are finding out in this particular experiment. Is it clear to you now?
Yes, sir.
Good. Okay, that's really good. Okay, now I want to ask Mukarrama, are you there? Yes, Mukarrama, are you there? Yeah. Do you have any doubt there?
No.
Okay, that's really good. So no doubt about it, right? Till now, whatever I have discussed with you?
Yes.
Very good. Now, let's move on to the last point. Result you have understood already. I discussed that it will be a graph, and on the graph, we have to show the whole thing. Now, come to the point of precaution. As I said, that whenever we do a practical, of course, it's a practical procedure, even though we are not doing it, but we have to show that we are doing it. And while doing, what type of problem we can come across and how to overcome it. That is our solution we have to explain at the same time. So I wrote the first point, as we said, Ohm's law first of all say that temperature should be constant. So when we are doing the practical, we have to ensure that the temperature is not going to change. So how to ensure that? First, if you just look at it, I wrote it, to keep the temperature constant, do not flow current for a long time to the circuit. So it means that whenever you are switching on the circuit, you'll be just checking the two values of the emitter and the voltmeter and immediately switch it off. Did you understand, girls, what I said? But if you allow this switch to be on for a long time, there is a possibility that the current will increase the temperature of the circuit. That will change the resistance of the resistor that you are measuring. So we are not going to do that. That is why we have to ensure that you're not passing electricity for a long time. Okay, girls?
Okay, miss.
Okay, who want me to repeat it?
No, she doesn't.
Yes, okay, fine, I'm saying. Girls, who's this L-E-U and someone? I don't recognize this student.
That's probably Mehreen. She came and left.
Oh, okay, okay, she came late. Okay, fine.
This is Lena.
Okay, fine, okay. So let me repeat this point. As I told you, that Ohm's law, first of all, informed us that we cannot change the temperature of the particular component or the resistor, if I mention now. So we need to do something that will allow us not to change the temperature of the circuit. That can be done by switching off the circuit very frequently. Means you just switch on the circuit, take the readings of the emitter and the voltmeter, immediately switch it off. Again, adjust the rheostat, go for switch on the circuit and then get the reading one more time. So you'll not keep on the circuit on and then adjust and then do the practical. That will, there's a chance that it will increase the temperature of the circuit. Clear now, Nashida?
Yes, miss.
Good. Now let's go for the next point. Check the ammeter and voltmeter for zero error. Means as you know that all the components can have a zero error all the time, means the pointer might not be at zero. So we have to ensure that we are placing the pointer of the particular meter to zero prior to the practical. So we have to ensure that. And the last one that I said, switch off the circuit in between readings. As I told you that you take one reading, switch it off, again adjust the rheostat, switch on the circuit and take the reading one more time. Okay, so like that we'll ensure that the temperature is not going to change, it will remain constant. That will give us the correct reading about the unknown resistance, and we'll find out all the values to be the same. Right, friends? Okay, now I want just you to turn the page, and there is something I wrote there. Check VI graph, means the practical that we did with you. We need to show it on a graph. And there I have mentioned 2 points, for ohmic conductor, for non-ohmic conductor. So for ohmic conductor is the one which follows the Ohm's law. Means here some conductors are like that, like you can see silver, copper, they are the ohmic conductors. Means if the temperature is kept constant, they will not change their resistance. So we are going to get a graph like this I showed you. I and V, a straight line from the origin that ensures that V and I are directly proportional. Then I gave you R and V, a straight line, means resistance remains same all three. Now, if you just look at the last point, that is for non-ohmic conductor, conductors which doesn't obey Ohm's law are called non-ohmic conductors. As I said before, tungsten, there's a even the filament lamp, the tungsten filament lamp or the nichrome wire, they actually are not ohmic conductors. According to the temperature, they do keep on changing their resistance. In fact, they do increase. That is why if you just look at the graph, you'll see I and V, the graph pattern is a curve now. Initially it is straight and after that it become a curve. And then if you just look at the RV curve, I showed you that it is increasing. These all curves are coming in mostly paper 2. They'll give you the pattern of the curve and they'll ask you which one is for ohmic conductor and which one is for non-ohmic conductor. Is it clear to you girls now?
Yes, miss.
Very
Yes,
good.
miss.
Okay, fine. Almost we are about to finish our class today. Inshallah, in my next class, I will go for the electrical working. And I think I might need 2 more class to complete this note. And then I can go for the past paper solving. Right? And I hope you girls will start learning whatever I discussed with you today and ensure that you're learning the notes thoroughly. That will help you to solve the past paper a lot. Okay? And girls, as I find only 16 students right now with me, could you just inform the rest of the girls to join my class? I'm not sure, are they included in this group?
Yes, miss, I guess.
But I don't know, is it like they're sleeping now? I don't know, I'm not sure. But I want them to be in my class. So, okay, next time, even yesterday I gave you the message, right? That today I'm going to have a class with you. I don't know why they couldn't make it. Hopefully they'll make it in the next class, right? Okay,
So,
inshallah. So girls, let us finish my class today. How was it for you? Did you enjoy?
Good.
It was
Yeah.
good.
Alhamdulillah.
It was good, but I wish I was in the class.
Yes.
Yeah, that is true. Even I miss the class with the board and explaining, drawing the circuit with you. I do miss that. But what to do, dear? Situation made us like that. We'll cope with it and inshallah we'll hope for the best. That's very soon we can join our classroom. Right, girls? We do miss our school a lot.
Yes, ma'am.
Yeah. Okay, guys.
Okay,
Let's,
miss. Bye. Take care.
yeah, you too, dear. Allah Hafiz. And inshallah, I will inform you in my next class as well. And I want the rest of the students to be here. Okay, Allah Hafiz. Take care.
Okay, bye, miss. Bye,
Bye, guys.
everyone.
Bye,
Bye.
everyone. Allah Hafiz.
Assalamualaikum.